What's up, scholars? Welcome back. I'm Ms. Atkin.
And I'm Lisa.
And today we are talking about
triangle properties. Woohoo! All right, so today in our lesson, we're going to talk about triangle properties. So before we get into any examples, I want to go over some basic things that we need to know before we start working. So the first thing that we need to know is that the three angles inside of a triangle add up to 180 degrees. They will always, always, always add up to 180 degrees. Now, another thing that we should know is that sometimes you're going to see a line following or coming off of that triangle, and that we can consider that right now our fourth angle. This exterior or fourth angle that we have will actually be supplementary to angle 3. Why is this supplementary, Lisa? Well, because it makes a line with angle 3, so they add up to 180 degrees. No. Yes. Okay. And then finally, the last thing that we need to know is that the measure of angle 4 is actually the measure of angle 1 plus the measure of angle 2 added up. So these are just some basic things people want to know before we get started.
All right, 3, 2, 1, go.
Let's put our new properties to use, and we're going to work through these examples. So our first question says, the sum of the interior angle measures of a triangle must be, and your answer is going to be 180 degrees. So then it says, so the measure of angle 1, measure of angle 3, and the measure of angle 4 will equal 180 degrees. So just always, always, always remember it's 180. Our next example says, we are given that the measure of angle 3 is 35 degrees. Right now, this may be useful, and I think it's always useful to always write in the angle measures that you're given inside your actual triangle. This kind of makes you feel a bit more organized, makes things seem a bit cleaner. So it says the measure angle 3 is 35 degrees. So that means that the measure of angle 1 plus the measure of angle 4 will equal
So they will just say, like,
yeah, I don't know what to say. I was like, what?
How would you solve for this? How would you solve for this?
So the measure of angle 1 plus the measure of angle 4. So I was given the measure of angle 1 already. So I would just say 49 plus x plus 35 is equal to 180.
Okay.
Can we do that?
Yep, so say all of those things that you just said. That would be great.
Okay, so
yep.
I'm going to say, since we're given the angle measure, our question says, and I'll start right there. Okay.
Yes. Yep. All right, 3, 2, 1, go.
So since we're given our angle measure, our question says, so the measure of angle 1 plus the measure of angle 4 is equal to something. So the way that I would actually go about solving this is going back up to our information, and we're actually also given the angle measure for angle 1. And angle 1 is actually 49 degrees. Miss Atkin marked it as 4, but just remember that's 1 up in the corner. So then the way that I would go ahead and solve this is say 49 plus 35, and that's due to the two angle measures that we already have at the top, plus x. And where am I getting this x? This x is just in place of measure of angle 4, since we have not gotten an angle measure for it yet. And then you would just set it equal to 180. So you would just solve for this algebraically. You would add 49 and 35 and then subtract that total from 180 to get the final angle measure for angle 4.
Actually,
yeah, this is going terribly.
Yeah, maybe it's just better to put the question on the paper.
That's okay. Yeah, because this is, I'm trying to like, ooh.
Yeah.
But it's okay. I'm good with us putting it on the paper.
Okay, cool.
And I was kind of like stalling in that one, so it's all good.
Yep.
Oh wow, that was fun, Miss Atkins.
Making videos is just the best.
Okay, so they called and they said, Carolyn, there is a dinner at Oakland, Suite 130. Ma'am, you have the wrong number.
Mm-hmm.
I said Carolyn. No. Wrong numero. All right. So now we're actually going to go ahead and work through our examples. Okay. So we did 1 and 2. So I don't ramble. For number 3 from the figure, we can see that the measure of angle 2 and angle 3 is equal to 180, like we talked about. And since that's 35, I should probably solve these, shouldn't I, Miss Atkin? Or no? No, I'll just talk slow. Do you want me to start again from the beginning?
Yes.
Okay, sounds good. Oh, since I'm on my phone, your screen cuts out. I'm gonna try my best.
For the very last one, we'll say the measure of an exterior angle is equal to the sum, and however you would say that, I guess, equal to the sum of the two non-adjacent angles, so equal to adding up the two angles that it's not next to.
Okay, so the measure of an exterior angle is the sum or the addition of the two angles that aren't near that exterior angle. So it would be angle 1 and 4, right? Okay, that sounds like something I would understand.
Okay, cool. All right. And 3, 2, oh wait, we're recording, so but I'm still gonna say it for my editing perspective. All right, 3, 2, 1, go.
So go ahead and put our new properties to use. So for our first question, it asks, or it says first, the sum of the interior angle measures of a triangle must be 180 degrees. So the measure of angle 1, plus the measure of angle 3 plus the measure of angle 4 will equal 180. So and then it says that we're actually given the measure of angle 3, which is 35 degrees. So I think it's always helpful to write this inside your triangle, as it just causes for organization. Make sure your paper look a bit cleaner when working out the math. And then it says it wants us to solve for the measure of angle 1 plus the measure of angle 3 plus the measure of angle 4. So how do we go about this? If we look back up in our information slot, we were also given the measure of angle 1, which is 49 degrees. So the way I would solve this, I would do 49 degrees plus the 35 degrees that we were given. And then plus the measure of angle 4, as we don't have that yet, is equal to 180 degrees. So then from here, we'll just add 49 and 35, and then we can go ahead and subtract that amount from 180 to get the measure of angle 4. So for this value, we have 96. So then our next question says, what will be the value or the degrees of measure of angle 2 plus the measure of angle 3? So if we remember from the beginning, these are actually supplementary, so they will actually equal 180 degrees. So how are we going to solve for measure of angle 2? Since we're given the measure of angle 3, we'll just solve this algebraically, and we'll put 35 plus the measure of angle 2 is equal to 180. Go ahead and subtract that 35 from both sides, and for that measure of angle 2, you will get 145 degrees. So that's just some basic algebra that we did there. Just remember to work through your problems, fill in those degrees inside your triangle to keep that organization. And then the last part that we're going to do for this example is the fact that the measure of the exterior angle, in this case being angle 2, will always be the sum or the addition of the two angles that are not nearest to it or adjacent to it. So in this case, it'll be angle 1 and 4. The way I would think of it is that they're not touching. So if they were at arm's length, angle 2 and 3, angle 2 to 1 and 4 wouldn't be touching. So that's how we know that it would equal the sum of it.
Beautiful. All right.
I think they'll be able to tell that this is live. They'll be like, she said, LOL.
I think that's fine. Totally good.
Okay.
All right. Our next one. We need to talk about isosceles triangles. Have their sides are the same measure, and their angles are the same measure.
Their angles are the same measure, right?
Yep.
Okay. So for an isosceles triangle, the key thing to remember is that the two sides are actually equal to each other, and that means that the two bottom angles are also equal to each other. So how are we going to go ahead and solve this? So since we know that this is an isosceles triangle, we know that angles B and C are equal to each other, and the full value is equal to 180. So we could go ahead and do 3x plus 20 plus 3x plus 20 due to the fact that B and C are equal to each other, plus 4x plus 10 is equal to 180. Okay, I can do that.
Excellent.
Are we behind it all or no?
What do you mean?
Like behind, like with your schedule?
I was going to see if you could meet tomorrow morning. If not, that's okay.
Yeah, that's okay. That's
Okay.
why I was, we
Gotcha.
didn't do that.
Yep.
So that's,
All right, ready?
yes.
3, 2, 1, go.
So our next step in our lesson today is going to be learning about isosceles triangles. So key thing to know about an isosceles triangle is that the two sides are actually equal to each other. So that just means that they will be equal in value, but this also means that the two bottom angles will be equal to each other as well. So the two sides are congruent and the two bottom angles are congruent. So this is, whenever you see isosceles, just think congruent, congruent. That's the key thing to remember here.
All right, now I'll put up this
Example.
question.
So for our example, we're actually going to be working with so for our example, we have three angles B, D, and C. We're given the value of angle B and angle D, but we don't have anything for C, and we also, okay, that's minimize. So for our first example, we're going to want to solve for the degree measure of each angle. So in that case, being angle B, D, and C. Okay.
All right, ready?
Yes.
3, 2, 1, go.
For our first example, we're actually going to want to solve for the degree measure of each angle in this triangle, in this case being angle B, C, and D. The first thing that we can see is that we don't have values for none of them. So what I would do first is see that this is an isosceles triangle, and I would immediately tell myself that angles B and D are equal to each other. So regardless of the fact that you're not giving anything for C, you know that C is also 3x plus 20. So how we will begin to solve this, we know that a triangle, all the angle measures are equal to 180. So we will do 3x plus 20 plus 3x plus 20, once again, plus 4x plus 10 is equal to 180. So the 3x plus 20 is there twice due to the fact that the bottom angles are congruent, and then triangle measures are equal to 180. So what we're going to want to do now is combine like terms and find the value of x. Finding like terms, subtracting 50 from both sides. And then value x, we get 30. All right. So once we have the value, you do realize we've solved for our variable, but we haven't solved for the actual angle measure. So what you'll want to do is plug this x back into each. First, you'll do 3, plug in the value of x, plus 20, and then solve. And then for your final answer, you will get that the measure of angle B is 50 degrees. Instead of going ahead and doing multiple work, since you know that B and C are equal to each other, you can go ahead and write for angle C that it is also equal to 59 degrees. And then for angle D, you'll just want to go ahead and once again plug in that value of x. The way that Miss Atkin did it, she actually added B and C and subtracted that value to finally get the measure of angle D. So those are 2 different ways that you could go ahead and solve for that final angle measure. Now, all 3 angles.
Beautiful. Sorry, I didn't even listen to what you said. I just went along.
It's okay. I like stuttered when I said the value of x and I didn't say the measure of angle D because since I'm on my phone, I screen.
Oh, gotcha.
So, I could just put it down. I'm just gonna put it like this sideways. I can see it better. But yeah, that's why I was kind of like stalling. I was like, ooh.
Gotcha.
But did that sound okay?
Yes. All right, for the next one, we need to talk about what it means to be a midpoint, and then a mid-segment connects 2 midpoints. So if JK is a mid-segment, it connects, like J and K are midpoints, is what that means.
What?
So the title of the question, yeah, the mid-segment just connects 2 midpoints.
Okay, so a mid-segment just connects 2 midpoints.
Yep.
All right. Are we going to do the example right away, or are we going to introduce it?
Well, we're finding x, y, and
So for our next example, we're going to talk about the mid-segment theorem. So what we need to know is that a mid-segment actually connects 2 midpoints. So that's just the key thing to know here. We're going to go ahead and do an example to...
Yeah, so also what's true, I'm going to draw the picture up. Also what is true in the mid-segment theorem is that JL is congruent to XK and KZ. Does that make sense?
Okay, JL is congruent to XK and KZ.
Yep.
Because JL is the base of the triangle and then XKZ is the base as well, right? Or no?
Yep, it's like, it could be like you have 4 little triangles there.
Mm-hmm.
Yes, and all 4 of those triangles they're all congruent.
And since that's the base, all their bases are congruent. Okay, that makes sense.
Yeah.
You want me to say that once we start the example? Or just all together? Are we going to do the example all together with the mid-segment stuff?
Let's talk about how J and L and K are all midpoints.
So you want me to mention how all those are midpoints, you said?
Yes. So we'll say all of those are midpoints. Which means like these are congruent to each other, these are congruent to each other, and these are congruent to each other.
Okay.
And then we'll say there's a special name for segments that connect midpoints. Those are called
And that is called mixed segment.
mid-segment.
Okay.
And then talk about how, like, you can kind of see that there's 4 triangles here.
4 triangles here.
Yep, and they're actually all congruent.
Okay. And then
So-
I'll say how I think about it as JL being the base and
Yeah.
that equaling the base of all the other 4 triangles. Okay.
Yep.
And then are we going to work the example right after we're done with that?
Yes.
Or are we
Yep,
gonna
on it.
stop?
Yeah, so we'll just keep going through and I'll put in the numbers and we'll work through the question.
Okay, so XZ is equal to 28. So then we can just divide 28 by 2 to see what those 2 small ones are. KL is 42. And then YZ is 76. So you just divide that by 2. Then XY. Okay.
Yep.
And then if I need to stop, I'll let you know. But I think we'll be fine.
Yeah, so talk about midpoints first, and then that they're mid-segments, or midpoints and what that means. And then mid-segments and what that means. And then we'll move into the
Okay.
Okay?
All right, sounds good.
3, 2, 1, go.
Now let's go ahead and talk about our mid-segment theorem. So we have this really big triangle, and we see that there are points J, K, and L. So I want us to see these points as actually midpoints, and what a midpoint does is that it actually breaks the sides next to it into equal values. So it just means that all those sides are equal to each other. So you see that Miss Atkin is saying which are equal to each other, the ones with one line are equal to each other, etc., etc. But then what is actually a mid-segment is a segment that connects to midpoints. So JL is actually a mid-segment due to the fact that it connects those 2 midpoints, and so on with the other 3 points. So what I want you guys to picture when working this is that you have 4 little triangles inside this big triangle. And the way that I looked at it is that if you look at our first triangle, JL is actually the base. So if you see JL, that looks like a base. And then if you see XK, that looks like another base. And then if you see KZ, that looks like another base. So I'm just thinking about these like, okay, these are all equal to each other due to their midpoints and due to the fact that they have those mid-segments connecting them. So now we're going to go ahead and work an example with this. And Miss Atkin is actually just pointing out which are equal to each other. So the ones with 3 lines are all equal to each other, the ones with 2 lines are all equal to each other, and the ones with 1 line are all equal to each other. And you can just think of this as the bases are all equal to each other, one side is all equal to each other, and the other is all equal to each other. So we're going to go ahead and write down the values that we're going to be given for this example, and then we'll go ahead and work through them. That sounded so choppy.
That was fine. Okay. And 3, 2, 1, go.
All right, so for XZ, we were given the value of 28. For KL, we were given 42. For YZ, we were given 76, and they want us to solve for those 3 other side lengths. So the first thing I would actually do is go ahead and just write these in. But we see that XZ, that full side is equal to 28. So if we wanted, we could actually split this into 2 if we find it more helpful. So we would just do 28 divided by 2, and we would see that both sides are equal to 14. Our next one says that KL is 42. So we just write that down, and we can go ahead and write that value in for the other sides as they are all equal to each other. And then we see that YZ is 76. So once again, we can go ahead and divide this by 2 to equal their measures since they're equal to each other. And then for each side, we will get 38. And Miss Atkin is just writing that value in for the other side that is congruent to it. So since we've solved for every side, we can just go ahead and fill in our values. So value of XY will actually be 42 plus 42, not just 1. So our answer there will actually be 84. And then when it asks us for the value of JY, we can actually just write in 42 since that is just a single value. And then for JK, we saw that it is the one with the triple line, so our value there is 38. So what made this problem very easy is the fact that Ms. Atkin went ahead and labeled which sides were equal to each other at the beginning of the problem to once again cause for that organization and just make the problem cleaner at the end.
Awesome. All right. Oh, 2 more.
I just feel like I'm doing so bad at this lesson.
You're doing fine. Also, some of these like we didn't explicitly talk about, so.
Yeah, if students ever come to you and are like, this didn't make sense, I would like you to bring to me constructive criticism.
Okay.
Someone said your voice, oh, I feel, I've heard students be like, this teacher's voice is so annoying. I'm like, oh, what if the students are like that about me?
Well, I mean, I guess you can kind of change your voice.
Be like, hello. Okay.
Yeah.
So inequality theorem. So next part in our lesson, we're going to talk about the inequality theorem. So the inequality theorem, is this just the one that says that A plus B has to add up to be greater than C to be a triangle?
Yes.
All right, so I can go ahead and do that. And then while I'm talking, do you want to start writing in the examples so that we can work through them, or is there something else you want me to say?
That's fine. Yep. Make sure you say C is the longest side.
Okay.
So the 2 littler sides have to add up to be bigger than the longest side to be a triangle.
Okay, sounds good.
Okay. All right. 3, 2, 1, go.
Next up in our lesson, we have the inequality theorem. So this theorem just says that in order to be a triangle, A plus B, which are the 2 small sides, must add up to be greater than C, which is the longer side. So C, you can think of it as a hypotenuse, as some people call it. So just remember, A plus B has to be greater than C. So we're going to go ahead and do some examples, and we're going to decide whether these side lengths can be a triangle or they cannot be a triangle. So for our first example, it says that A is 6, B is 6, and C is 21. So if we did 6 plus 6, we'd get 12, and we would see that isn't, in fact, greater than 21, so this cannot be a triangle. Our next example says that the value of A is 9, B is 10, and C is 17. 9 plus 10 is 19, and that is, in fact, greater than 17, so this can be a triangle. And then for our third example, it says that A is 4.1, B is 18, and C is 21.2. So if we did A plus B, it would, in fact, be greater than C. So this can also be a triangle. So the key thing to remember here is my 2 smaller sides have to add up to be greater than my long side.
Beautiful. That one was so fast.
I think because it was just like a simple like boop, 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 boop.
Yep.
And then the other one took forever because it didn't work with the writing thing.
Well, that's true.
Okay. So now we're going to talk, how do you pronounce this? The hinge theorem?
Hinge, yep.
Hinge, okay. So last in our lesson is going to be the hinge theorem. So with this theorem, we're going to decide if 2 triangles are less than, greater to, or equal to each other. And the way that we're going to do this is that the angle across from what side did you say?
Hang on just a second.
Okay. Attention, attention. Say future presidents of America.
Okay, so for the hinge theorem, The biggest side is across the biggest angle, but first we have to know that two sides of a triangle are congruent. So like
Okay.
the first question, actually, we can't determine it because we don't have two sides that are congruent to, oh yes, we do.
Yeah, the 12 is right.
Yep, never mind. So in
Okay.
this one, we'll want to say, like, we know that BD is part of both triangles and it has to be congruent because it's the exact same segment. So
Okay.
I'll like add in a congruent mark there.
Okay, so for our hinge theorem, the first thing that we're going to want to know is that when we have the two triangles, one of the sides has to be congruent in the triangles, or a pair of sides has to be congruent.
Yeah, a pair of sides. So if you know a pair of sides are congruent,
then
then
you know then you can go along with the hinge theorem.
yes. Yep.
Okay, so for our hinge theorem, the first thing we're going to want to know is that we must have a congruent pair of sides in order to keep going along with it. Otherwise, you could say that it cannot be determined. And
Yeah,
then,
so let's say like we're making a hinge, like
okay,
that's where it's coming from. You know, we know this hinge is the same as the other hinge side. If we know that's the case, then we can compare the angles that those hinges make with each other.
okay, sounds good. And then how did you want me to describe the angle that's across from did you say the biggest side?
Yes. Yeah, so first we'll talk about making a hinge.
Okay.
And we want to compare hinges that are the same length. So like this is your door maybe,
Mm-hmm.
and they're the same size door.
Okay, so now we're going to talk about our hinge theorem. So before we get into it, let's make a scenario in our head that we are making hinges. We want to compare the lengths of two hinges, but in order for us to do that, one pair of sides must be congruent. Does that sound good?
Yes, I'm actually wondering.
Okay, I'm just having trouble with this because I feel like have I seen this before?
No, you have not.
Okay, I'm just a little. This one you can tell me what to say word for word, and I'm okay.
That's okay. And also my partner just reminded me that we need to leave in 5 minutes. So I'm thinking we'll stop our video here.
Okay.
And then we'll pick back up tomorrow. Are you able to do tomorrow at 10?
Yeah, I can do tomorrow at 10. And if you want, we can run it a little longer so we can finish this one and then do another one.
Okay.
That sounds good to me.
Okay, cool. All right.
And then I might want to look into this so I look a little bit more